on section 4.6, which is called Cramer's Rule. And here today we're going to be able to solve some system of equations with determinants and things using matrices. I will warn you, these are some long problems, so that's why you'll notice there's only 3 examples on this paper, because they do take a little while to solve. So go ahead, grab a snack, settle in, and get ready. Alright, Cramer's Rule uses determinants to solve systems of equations. And on your paper you'll see a couple of systems directly under this definition. Go ahead and skip down to the next system where you'll see x equals blank and y equals blank, and you're going to fill in these determinants with the x equals and the y equals. And I'll kind of explain here in a minute once we actually get to an example how we're going to use those, but essentially you're just pulling numbers, the coefficients and the solutions from those systems and setting them up like this. I do want to make one quick correction here. I do believe that should be a B here. I must have mistyped that when I did that. As I'm looking at this, that should be a B. So both the denominators should be the same with A, B, C, and D. Alright, so let's go ahead and jump into an example here. So I have a system where we have 5x plus 7y is equal to 13, with 2x minus 5y is equal to 13 as well. So we're going to start with the x value here. So we have x equals, and again we have those definitions. I'm not going to rewrite all those letters every time because that's kind of unnecessary. Really what's happening here is when you do Cramer's Rule, you're going to take the coefficients of the variable you're solving for and remove those and replace them with these. So the first two here are going to be 13 and 13 in that x column, and then we're going to leave the y's. So then we have 7 and negative 5. And then down below we just take these 4 over here. So we'll have 5, 7, 2, and negative 5. So when we take the determinants of these, remember we cross multiply. So on the numerator up here we're going to have 13 times negative 5 minus 7 times 13. That's all over, cross multiply, we have 5 times negative 5 minus 7 times 2. So we'll set that equal to 13 times negative 5 is a negative 65, minus 7 times 13 is going to give us an 91, all over negative 25 minus 14. And so we get negative 65 minus 91 is going to give us a negative 156 over a negative 39. And when we divide that out, we end up with 4. And so that's our x value. So again, I'm not saying this is necessarily quicker than solving it by using systems. It's just an another way of doing it. Alright, I'm going to go ahead and erase this. If you need to go back and pause the video or review that, go ahead. I'm going to go ahead now and we're going to do the y value. So 4 is our x value, so we're going to go ahead and remind ourselves of that. Write it up here. Now to do Cramer's Rule for the y value. Again, in the top, because we have the x's here, we're going to leave those and replace the y's with 13 and 13. And the denominator, the same thing we had before. So we're looking at having the exact same denominator, so I don't have to redo it. We knew before it's negative 39. So we just have to do the determinant up top. So we have 5 times 13 minus 13 times 2 all over negative 39. So again, we get 65 minus 26 all over negative 39. We get 39 over negative 39, which is negative 1. So our coordinate would be 4, negative 1. So if you wanted to solve this using substitution or elimination with this, you could, and you should get the exact same answer of 4 and negative 1. Let's go ahead and take a look at another example. One thing I did mean to say before is that this is something else that you will not have to memorize. Cramer's rule will be given to you, so those setups that you copy down, the x equals and the y equals, that will be on the test for you with the determinant things, or excuse me, with the transformation things that I'd given you beforehand for the reflections and rotations. So with reflections, rotations, and then Cramer's rule, those things will all be on that cheat sheet that I told you I was going to give you. So let's go ahead and solve for x and y here. So x is equal to the determinant of negative 2, 13, negative 2, and 3, all over these four. So we'll have 4, negative 2, negative 1, and 3. Cross multiply. So we're going to get negative 6 minus a negative 26. We get plus 26. All over, cross multiply, we get 12 minus 2. So here we end up with 20 all over 10. That's going to give us a positive 2. Now let's go ahead, I'll come over here and we'll do the y values. So we're going to get y is equal to the determinant of 4 over negative 1, and the negative 2 and the 13 will go in here in place of the y's, all over the same thing that we had before, which was 10. We come down, cross multiply, 4 times 13 is going to give us 52, minus 2 all over 10, 50 over 10 is 5. So our coordinate here would then be 2, 5. So the more you get the hang of this, the more you're practicing it, it will go faster. Doing those determinants, if you don't write out all those steps, it does go faster that way, but not all the time. So sometimes it just kind of depends on how you want to solve things. But for this chapter, you are not to do substitution and elimination. You are only to be using Cramer's rule to solve these, just so you can get the practice and the habit of how this rule works. Okay, you can also do this with 3 variable systems. However, with 3 variables, we need 3 by 3 determinants. So when we have 3 by 3 determinants, again, the denominator is the same across the thing. So once you find that 3 by 3 determinant once, it'll be the same for all 3 variables. And again, for that x determinant, you're going to replace the x column with the solutions from the one side, the y column in the middle one with the JKL solutions, and then for the z column, it would be that third column that you're substituting with those solutions at the end. Excuse me, with the equals, with the constants. So, for each one of these, we have a 3 by 3 determinant. Again, you could either do that by diagonals, or you could do that with expansion by minors. So let's take a look at this 3 by 3 determinant. We're going to go ahead and solve this using our 3 by 3 determinants. So we have x equals, and I'm going to replace this one with the negative 1, negative 9, and negative 5. And then we have 1, 5, negative 2, 1, 3, negative 1, all over, and then we just take these 9 numbers on this side. So we have 3, 1, 1, negative 6, 5, 3, and then 9, negative 2.
Nope.
Okay, so here is your homework. Here's your homework that you will be doing for this section. It's a 7 through 12 all, 18 through 28 even.